In this video, let's go ahead and practice applying our exponent properties involving products and quotient properties together. And just so you're aware, this is a part 2 video, so if you're looking for something that's a little bit easier without all these coefficients, you can go ahead and check out one of my previous videos on the same concept, just with not as many difficult problems. In each of these problems, we're going to go ahead and practice simplifying these exponential expressions that have coefficients with them as well. So let's go ahead and start by identifying what our coefficients are. We'll go ahead and deal with those, then move on to the exponents with the variables. So on top, let's use 4 times 2, use the commutative property and just multiply in any order. And then we can go ahead and see the 10 on the bottom is actually just going to stay the same, right? We can't really do anything with that just yet. And if you take a look at these variable parts, a to the second power times a to the fifth power, you can use that product property. 2 plus 5 is going to be 7, so it's going to be a to the 7th power. Now on the bottom, we're going to leave this a to the 3rd power alone and just write that right next to this 10, so 10a to the 3rd power. All right, let's move on and let's go ahead and simplify these coefficients. So 8 over 10, just treat this as a normal fraction. So what can you divide these both by? Well, their GCF is going to be 2, so let's go ahead and divide both of these coefficients by 2. If we go ahead and do that, then we're going to end up with 8 divided by 2 is going to be 4. And then 10 divided by 2 is going to be 5. Let's go ahead and put a 5 here. And then looking at this a to the 7th power divided by a to the 3rd power, we can use that quotient property and subtract those exponents. 7 minus 3 is going to be 4, so it's going to be a to the 4th power. We're always going to put that on top after we subtract. Okay, so we can go ahead and write this answer a couple of ways. One way is I'm just going to clean this up and center it a little bit. So I'm going to write 4a to the 4th power here. This is going to be all over 5. This is one way of writing our simplified expression, or we can write this 4/5 as a coefficient like this. We can write 4/5 multiplied by a to the 4th power. So this is another way we could write our expression. All right, here is number 2. For number 2, let's go ahead and do a very similar process here. Noticing the coefficients, we have a 4 and a 3 and a 16. Let's go ahead and deal with those first, right? So just dealing with the numerator, 4 times 3 is going to be 12. And the 16's on bottom, let's just leave that alone for now. Moving on to the variable parts, we have b to the 5th times b to the 7th. We can use that product property and add 5 plus 7 to get 12, so b to the 12th power. And then on the bottom, let's just keep this b to the 6th as it is for a moment, so b to the 6th power. Looking at these coefficients, 12 and 16, what's their GCF? Well, we can divide this one by 4, right? And we can divide this one by 4. If we go ahead and do that, 12 divided by 4 is going to be a 3. And then 16 divided by 4 is 4. All right, moving on to these exponents, these powers. So b to the 12th divided by b to the 6th. We can use that quotient property. 12 minus 6 is going to be 6, so it's going to be b to the 6th power. Okay, so we can go ahead and just clean this up a little bit and just write this is going to be 3b to the 6th power. And put that over 4. Just go ahead and center that a little bit. And then you can also write this using a coefficient. If you want to say this is 3/4 multiplied by b to the 6th power, you're also welcome to write your solution that way too, or the most simplified expression. Here's number 3. Number 3 is pretty similar looking to the last few. So we have this 3 and 5 and 10 for these coefficients. Let's go ahead and deal with those. So let's do the product on top first. So 3 times 5 is going to be 15. And then the 10 is just going to stay as a 10 on the bottom for now. Then looking at our variable parts here, we have c to the 4th power times c to the 4th power. Using the product property, 4 plus 4 is going to be 8. So we're going to have c to the 8th power. And then on the bottom here, let's just keep the c to the 5th power as it is for now. Alrighty, and then let's go ahead and now simplify these coefficients using just division. The GCF of 15 and 10 is just going to be 5, so let's divide by 5 and divide by 5. If we go ahead and do that, 15 divided by 5 on top, that's going to be 3, and then 10 divided by 5 is going to be 2 on bottom. Then using that quotient property, c to the 8th power divided by c to the 5th power, we can say 8 minus 5 is going to be 3, so it's going to be c to the 3rd power. Again, put that on top. All right, so let's go ahead and center this a little bit. Let's see, this is going to be 3c to the 3rd power over 2. Or we can also write this using a coefficient. So we can say this is going to be 3/2 multiplied by this c to the 3rd power, just like this. Here's number 4. For number 4, and this one also looks pretty similar, so if you want to go ahead and start practicing these on your own or checking, you can go ahead and see. Let's look at these coefficients first. I'm going to do the product of the numerator coefficients, so 6 times 3, that's going to be 18. And I'm just going to leave that 12 alone for now on the bottom. And then let's take a look at our variables. We have d to the 5th power times d to the 3rd power. Using that product property, 5 plus 3 is going to be 8, so it's going to be d to the 8th power. And then for the denominator, let's keep this d to the 7th. Just leave that alone for now. So d to the 7th, just like this. Alrighty. Now let's go ahead and take a look at our coefficients now. We just have one on top, one on bottom. So what's their GCF? I think it's going to be 6. We can divide by 6 and divide by 6. If we go ahead and do so, 18 divided by 6 is going to be 3. And then 12 divided by 6 is going to be 2. Moving on to these variables, we have d to the 8th power divided by d to the 7th power. Using that quotient property, 8 minus 7 is 1. So we're going to write d to the 1st power here. All right, so we can go ahead and clean this up a little bit and just say this is going to be 3, instead of 3d to the 1st power, just say 3d. And this is going to be over 2. All right, so this is one way to write it, or you can also write it using a coefficient and say this is going to be 3/2 multiplied by d. Put that right next to that fraction bar. All right, here is number 5. For number 5, this is the first one that looks a little different. If you want to try to see what's different about it, you can try to notice that there is a product on top and a product on bottom. On the bottom, notice there's 2 coefficients technically, so there's an invisible 1 that is basically in front of this e to the 9th power. So I'm just going to go ahead and write that in so you can kind of see what's going on there. And so just be careful about knowing what types of invisible things you might be seeing or not seeing. On top, 8 times 4 is going to be 32, right? And on bottom, 4 times 1 is going to be 4. So that's why that's going to stay as a 4. Moving on to these variables, we have a product on top, so e to the 3rd times e to the 9th. Using the product property, 3 plus 9, that's going to be to the 12th power. All right, and let's use the product property again on the bottom. So e to the 2nd times e to the 9th. Using that product property, 2 plus 9 is 11, so it's going to be e to the 11th power. All right, let's keep going here. It looks like we have a couple things that we have to simplify. So if we look at the coefficients, 32 and 4, this has a GCF of 4. So we can divide the top by 4 and the bottom by 4. If we do that, 32 divided by 4 is going to be 8. And then 4 divided by 4 is going to be a 1. We don't have to write the 1 in a little bit. I'm just writing it to be more clear right now. E to the 12th divided by e to the 11th, using that quotient property. 12 minus 11 is going to be 1. So it's going to be e to the 1st power. Now what's a more simple way to write this? Well, we can also write that this is going to be, well, 8 divided by 1 is just 8. So we can just say this is going to be 8e. And this would be our most simplified expression. Here's number 6. So for this one, our coefficients are 3, 6, 9. Don't forget there's also this kind of 1 hanging out here. We just don't write it, but just know that it is there. All right, so let's deal with these coefficients first, just like we've been doing. On top, 3 times 6 is going to be 18, so it's going to put an 18 up here. On bottom, 1 times 9 is going to be 9. Now moving on to the variables, f to the 8th power times f to the 3rd power. Using that product property, 8 plus 3 is 11, so it's going to be f to the 11th power. And then in the denominator, we have f to the 2nd power. Let's go ahead and multiply that by this f to the 1st power. So don't forget there's an invisible little 1 there. And so using the product property, 2 plus 1 is going to be 3. So this is going to be f to the 3rd power. Okay. Now let's go ahead and see if we can clean this up more. Let's see, we have 18 over 9. What's the GCF of 18 and 9? I think it's just going to be 9. So we can divide these both by 9. If we go ahead and do so, what's 18 divided by 9? That's going to be 2. And then 9 divided by 9 on bottom is going to be 1. Moving on to the f to the 11th power over f to the 3rd power, we can use that quotient property. And 11 minus 3 is going to be 8. So it's going to be f to the 8th power. All right. Now dividing anything by 1 is just going to stay the same. So we can go ahead and say this is going to be 2 times f to the 8th power. This would be our most simplified expression. All right, here is number 7. For number 7, let's take a look at these coefficients. We have a 4 and a 4 and a 2, and then technically we have a 1 here. Not going to make a big difference, just be aware, okay? Let's start with these coefficients and multiply them to find their products. So on top, 4 times 4, that's going to be 16. On bottom, 2 times 1, that's going to be 2. Then moving on to these variables, we have g to the 7th times g to the 4th power using the product property. 7 plus 4, that's 11. So g to the 11th power. And then on the bottom, we have g to the 2nd power times g to the 5th power using that product property, 2 plus 5 is 7, so g to the 7th power. Alrighty, so let's go ahead and deal with these coefficients a little bit more. So we can go ahead and take a look at this 16 and 2 and see what's their GCF. Well, GCF is going to be 2. They're both even numbers, and 2 can't go any smaller. So dividing these both by 2, 16 divided by 2 is 8. 2 divided by 2 is 1. Moving on to the variables, g to the 11th over g to the 7th. Using that quotient rule, quotient property, 11 minus 7 is going to be 4. So it's going to be g to the 4th power. Now anything divided by 1 just stays the same, so we can just write this as 8g to the 4th power, and this would be the most simplified version of this expression. All right, here is number 8. For number 8, let's go ahead and start with the coefficients. So take a look at this 9, this 2, this 6, and technically there's a 1 here. All right, starting with those, let's see if we multiply these coefficients together. 9 times 2 on top is going to be 18. On bottom, 1 times 6 is going to be 6. And moving on to the variables, h to the 4th times h to the 14th, using the product property, 4 plus 14 is 18, so h to the 18th power. And on bottom, looks like we have this little 1 as an exponent, so keep that in mind. This is h to the 5th times h to the 1st. Using the product property, 5 plus 1 is going to be 6, so this is going to be h to the 6th power. Alrighty, so going from there, we can go and see that we have 18 and 6. What's the greatest common factor? I think it's going to be 6. Dividing this by 6 and dividing this by 6. 18 divided by 6 is going to be a 3. 6 divided by 6 is 1. And then for these variables, h to the 18th divided by h to the 6th, using the quotient property, 18 minus 6 is 12. So we're going to have h to the 12th power. And then dividing by 1 just stays the same, so we can write this as 3h to the 12th power. All right, cool. Let's check out number 9. All right, so number 9 is the first practice problem where we're dealing with some negative exponents. So starting with our coefficients, just like we've been doing, let's not do anything different just because we have negative exponents. We'll just talk about how to deal with that in just a moment. On top, 4 times 2 is going to be 8. On bottom, we just have this 8, so let's just leave that alone. Let's use the product property on top here. So you have I to the negative 4th times I to the 8th. But let's see, if we go ahead and take a look, what is negative 4 plus 8? Negative 4 plus 8 is just going to be a positive 4, so adding those little exponents together. So we're going to say that's going to be I to the positive 4th power. And let's not do anything with this I to the 2nd power just yet, so let's leave that as I to the 2nd power. Now, looking at these coefficients, 8 and 8, what's their GCF? Their GCF is just going to be 8. All right, because 8 over 8 is equal to 1. So let's go ahead and just say this is going to turn into a 1 and a 1. I'm just going to write them in for now. We'll go ahead and get rid of them later. Now dealing with these powers here, I to the 4th power divided by I to the 2nd power, using that quotient property, 4 minus 2 is going to be 2. Now anything divided by 1 is just going to stay the same, so we technically have 1i to the 2nd power. And then 1 times anything is going to stay the same as well, so it's just going to be I squared, or I to the 2nd power. All right, cool. Let's go ahead and check out number 10. For number 10, let's go ahead and start with the coefficients. So we have a 5, a 3, and a 10 here. Let's go ahead and deal with those. So in the numerator, 5 times 3, that's going to be 15. It's going to put a 15, and then the 10 is just going to stay the same. Moving on to these powers, let's go ahead and multiply these, and then we're going to use that product property. So if we do that, we're going to add these exponents. So negative 3 plus 4, that's going to equal positive 1. So in numerator, this is going to turn into j to the 1st power. And then in the denominator, let's just go ahead and copy down this j to the negative 5th power for a moment. Okay. Now let's go ahead and go further. I think we can clean this up a little bit more, right? So we have 15 over 10. Their GCF is 5. So let's go ahead and divide this by 5 and divide this by 5. 15 divided by 5 is going to be a 3, and 10 divided by 5 is going to be a 2. Now looking at these powers, we have j to the 1st power divided by j to the negative 5th power. We're going to go ahead and subtract. We're going to say, what is 1 minus this negative 5? Now 1 minus negative 5 is the same thing as 1 plus 5, right? If we add the opposite, and 1 plus 5 is going to equal 6. So if we go ahead and subtract, this is going to turn into j to the 6th power. All right. Now, if we go ahead and just center this a bit, we can say one way to write our answer is going to be 3j to the 6th power, and that's going to be over 2. this would be a totally fine answer. Or if you wanted to write it using a coefficient here, it would be 3/2 as the coefficient multiplied by j to the 6th power. So either way, these would be good simplified expressions. All right, here is 11. For 11, let's go ahead and use the same process here. We have our coefficients of 9, 4, and 6. So let's go ahead and start with those. On the top, 9 times 4, that's going to be 36. So let's go ahead and put a 36 here. And let's not do anything with that 6 just yet on the bottom. Moving on to the variables, we have k to the negative 5th power times k to the 9th power. Using our product property, we can go ahead and add those exponents. So negative 5 plus 9, that's going to be a positive 4. So we know this is going to be k to the positive 4th power on top. And on the bottom, let's not do anything yet. Let's just copy down this k to the 8th power. All right. Now let's go ahead and see what can we do with these coefficients. We have 36 and 6. So 36 and 6, I think we can divide these both by 6, right? That would be their GCF. Now 36 divided by 6 on top is going to be 6, and 6 divided by 6 is going to be 1 on bottom. We move on over to this k and k. These we have a quotient here, so we're going to subtract these two powers as our quotient rule, right? So let's go ahead and say this is going to be 4 minus 8. Now 4 minus 8 is the same thing as 4 plus negative 8. That's going to be a negative 4. So going ahead and subtracting using that quotient rule, this is going to be k to the negative 4th power. Now, if you're being asked to write this using positive exponents only, then you would go ahead and go a little bit further here. You would keep this 6 on top, this 1 on bottom. But if you're asked to write this using positive exponents, then you would go ahead and take this k to the negative 4th power and move it down to the denominator. And if you do so, then it becomes k to the positive 4th power. All right, so one way you could write this solution would just be writing 6 over k to the 4th power, just because that would be one way to write it using positive exponents. Another way you could be asked to write this, though, is to use no fractions. And if you were asked to use no fractions, then you would just write 6k to the negative 4th power. So two ways to write this final expression. One would be over here using no negative exponents. One would be over here using no fraction bar. All right, so for number 12, we have some coefficients. Let's go ahead and get started with those like we've been practicing here. So hopefully you're getting a little bit more comfortable here. 6 times 2 is going to be 12. Let's put a 12 on top. Then we have this 8 on bottom. Leave that alone. Moving on to these variables, we have L to the 5th power times L to the 3rd power. Using that product property, 5 plus 3 is going to be 8. So I'm going to use this cursive L. This is going to be L to the 8th power. In the denominator, we have L to the negative 9th power. So let's go ahead and write that down as L to the negative 9th power. All right, let's go ahead and simplify this a bit. So if we take a look, this 12 and 8, what can we divide these both by? I think we can divide these both by 4, right? Divide that by 4 and divide this by 4. If we do so, 12 divided by 4 is going to be 3. 8 divided by 4 is going to be 2. Moving on to these variables, we have a quotient. So using that quotient property, we can go ahead and take that exponent of 8 and then subtract the exponent of negative 9. 8 minus negative 9 is the same thing as 8 plus 9. And 8 plus 9 is going to be 17. So using that quotient rule, we can simplify the variables here and say this is going to be L to the 17th power. Okay, so we can go ahead and rewrite this as 3 L to the 17th power, and that's just over 2. Or we can also write this using a coefficient and say this is going to be 3/2 multiplied by this L to the 17th power. All right, here is 13. For 13, let's go ahead and start with coefficients. We have 8 and a 2 and a 6. So let's go ahead and say 8 times 2, that is going to be 16. So I'm going to put 16 up here and leave the 6 down here. And if we go ahead and go on to these variables, we have m to the negative 5th power times m to the 2nd power. So let's go ahead and use our product property. So we have negative 5 plus 2. We're going to add these exponents. Negative 5 plus 2 is negative 3. So I'm going to go ahead and write this is going to be m to the negative 3rd power. Okay. On the bottom, we have m to the 9th. Nothing to do with that just yet. So I'm going to leave that as m to the 9th power. All right, moving on, let's see here. We are going to start with these coefficients again. So 16 over 6. I think their GCF is just 2. So we can divide this by 2 and divide this by 2. 16 divided by 2 is 8. And then 6 divided by 2 is going to be a 3. Moving on to the variables. m to the negative third power divided by m to the ninth power. Using that quotient property, it's going to be this negative 3 minus 9, which is negative 3 plus negative 9. And that's going to be negative 12, right? So that's what we're going to get when we use that quotient property. So we're going to get m to the negative 12th power, all right? Now, if we go ahead, we can also write this as, I guess not rewrite, but just kind of write it a little bit more centered. So 8m to the negative 12th power over 3. This is one way we could write it. If we want to use positive exponents only, we can move this m to the negative 12 to the bottom. And so if you're asked to do that, then we would just write this as, let me go ahead and write this as 8 on top. And you're going to have a 3 and then times m to the 12th power on bottom. So again, this would be a similar or this equivalent expression that you could write using only positive exponents. But you can also write this as 8/3. If you want to write the 8/3 as a coefficient multiplied by m to the negative 12th power. All right, so either way you can go ahead and write this. This is using only positive exponents. This is using, I guess, technically no fraction bars. The coefficient, I guess, doesn't really count for that one, but that's one way to write our expression. All right, here is 14. For 14, this one's starting to get a little bit more messy looking here. So let's start with the coefficients and try not to be too overwhelmed. There are just a lot more pieces here, but it's the same idea, right? So let's go ahead and just look at all our coefficients and then use the same process. So on the top here, 3 times 7, that's going to be 21. And then on the bottom, 14 times 1 is going to be 14. So that takes care of cleaning up our coefficients a little bit. Then moving on to our variables, we have n to the negative 6th power times n to the 13th power. So using that product property, we can say negative 6 plus 13. That is going to be a positive 7, right? So that's going to be n to the 7th power. That's going to be on top. And on the bottom, we have n to the negative 6th power times n to the negative 1st power. Using the product property again, we can say negative 6 plus this negative 1. That's going to be negative 7. So this is going to be n to the negative 7th power. All right, so already hopefully you're noticing this looks a little bit less scary than it did just a moment ago using those product properties. Then let's go ahead and clean this up even more. So 21 and 14, these coefficients, their GCF I think is 7. So let's go ahead and divide these both by 7. If we do that, 21 divided by 7 is 3. 14 divided by 7 is going to be a 2. And then looking at these variables, we have this 7 and negative 7 for these exponents. So using the quotient property, we can go ahead and say 7 minus negative 7. So it's going to be 7 take away a negative 7. That's the same thing as 7 plus 7, right? So 7 plus 7 is equal to 14. So using that quotient property, we can simplify those variables to n to the positive 14th power. So we can go ahead and also rewrite this as a 2 on the bottom in the middle, and then 3n to the 14th power. Or if you want to write this using a coefficient, we can say, or a more clear looking coefficient, we can say this is 3/2 multiplied by this n to the 14th power. All right, here's just a couple more. The variable for this one is going to be O, just so that's not too confusing, but just wanted to practice using some different variables here. So we have a coefficient of 8 and 5 and 30. So I'm just trying to highlight these so it's very clear what's what. And we do have a coefficient here of 1 in front. So these are our 4 coefficients that we're working with here. Hopefully these zeros and O's don't look too similar, but this is generally why we don't use O, right? A little confusing. So 8 times 5 is 40 on top. On bottom, 1 times 30 is going to be 30. So hopefully that clears that part up a little bit more. And then using our product property, let's see, this O to the negative 1st power times O to the 5th power. Our product property says we can add these exponents. So negative 1 plus 5 is going to be a positive 4. So we're going to go ahead and write O, right, kind of like a cursive O to the 4th power. Okay, that's going to be on top, and then on the bottom we have O to the negative 3rd power times O to the 11th power. That's going to be a negative 3. That's going to be multiplied by O to the negative 3rd power times O to the 11th power. We can use that product property and add negative 3 plus 11, and that's going to be 8. So it's going to be O to the positive 8th power. All right. Let's go ahead and take a look at these coefficients. Their GCF is 10, so we can divide this by 10 and divide this by 10 as well. So 40 divided by 10 on top, that's going to be 4. And then 30 divided by 10 on bottom is going to be a 3. And then moving on to these powers here, we're going to use that quotient rule. So it's going to be this 4 minus 8. We can subtract those exponents, right? So 4 minus 8 is going to be 4 plus negative 8, and that's just going to be a negative 4. So using that quotient property, this is going to be O to the negative 4th power. Now, if you wanted to write this using positive exponents only, then you would keep this 4 on top. This 3 stays on bottom, but that O to the negative 4th can go to the bottom and become O to the positive 4th power. So this is one way we could write our solution, or using another way we can write our 4/3 as a coefficient. Say it's 4/3 multiplied by this O to the negative 4th power. All right, so those are two ways we could write our simplified expression. Finally, one last example here for number 16. Let's go ahead and give this a try. We have 4 of these coefficients. Let's go ahead and work with those first. On top, we have 8 times 3. 8 times 3, that's going to be 24. And on the bottom, 6 times 4, that's also 24. So that's actually kind of nice, right? Those are going to cancel out for us. Moving on to these powers, we have p to the negative 13th power times p to the negative 7th power. So if we use that product property, then we're going to have this negative 13 plus negative 7. Negative 13 plus negative 7 is just going to be negative 20. So we're going to go ahead and say this is going to be p to the negative 20th power. In the denominator, we have p to the negative 5th power times p to the 16th power. Using that product property again, that's going to be negative 5 plus 16. That's the same thing as 16 minus 5, and that's going to be 11. So this is going to be p to the 11th power in the denominator. Let's go ahead and simplify these coefficients more. So 24 and 24, they're the same number, so their GCF is just 24. So dividing these both by 24, this should make this look even less messy by going ahead and canceling those out. They both become 1s, right? Again, I'm just going to write those for now and then get rid of them later. So then we have p to the negative 20th divided by p to the 11th power. And this is where we can use that quotient property. And so we can subtract. We can say this is going to be negative 20 minus 11, which is the same thing as negative 20 plus negative 11, which is equal to negative 31. All right, so we can go ahead and just write this as p to the negative 31st power. That's going to be in the numerator. And so if we wanted to go ahead and write this using no negative exponents, then only 1 is going to stay on top. And then the p to the negative 31st is going to go to the bottom. And that's going to be p to the positive 31st power. I'm not writing that 1 down there. So you could write our simplified expression just like this, or you could also just simplify and say this is going to be 1 p to the negative 31st power, which again, if you take away that 1 there because it doesn't make a difference in the value, this would be p to the negative 31st power. Alrighty, so there you have 16 different practice problems where we are dealing with some of these exponent properties, specifically the product property and the quotient property. In this video in particular, we started off with 8 problems with no negative exponents, but then we had 8 with negative exponents, and we also had some coefficients that we had to take care of and simplify as well. So if you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.